There's different strategies for using alkynes in your synthesis. If you start with an alkyne and we add H2 platinum, that gives you the alkane. If you use Lindlar's catalyst or sodium and ammonia, we have an alkene, and you can do any of the reactions from chapter 9. This is a functional group here. And we still have that here, but at this point, when you get to the alkane, this is loss of functional group handle. Halogenation of an alkene followed by 2 dehydrohalogenation reactions can decrease saturation. If we have an alkene, we add Br2 plus tetrachloromethane. We're going to brominate it like we did before in chapter 9. And now if I add excess NaNH2, this is the strong base. That will do E2 reaction. And since there's excess, we can do a double elimination there. And that's how we can get an alkyne. If we react the alkyne with the Lindlar's catalyst or this other reducing reagent, we get the alkene. We get H2 platinum. That will get us to the alkane. And in the next chapter, we'll see how we can go from alkane to alkene. But if you want to go from alkene to triple bond, we need to add 2 bromines there, excess NaNH2, the base, followed by water to get that alkyne. If and when you are asked to do a synthesis problem, there's 2 strategies that you can go about this. One is to go forward, the other is to go backward. As we did in class one day, you want to make a couple of observations about what is happening in between the 2 molecules. If I look here initially, I still have this double bond. There's still a double bond here. I've also added 1 carbon. We currently do not have a way to add a carbon to an alkene. The only reactions that we have that can add carbons is via an SN2 reaction with something like sodium cyanide, but we can't go from cyanide to methyl group. So we're going to have to go through an alkyne. So if I work backward and do a retrosynthesis, I'd have to have an alkyne here, and then have to build that before I can go to the alkene, and the alkyne there before that would be a terminal one. And there's ways that I can go from alkene to alkyne. The one way that I know how to make an alkyne is through a dihalogen, which I can get from the alkene. So if I go in the forward direction, in order to put the BRs in that fashion, I can go BR2, and that will add my 2 BRs. And then I can add the excess NaNH2 in ammonia, followed by water. So that will get me my triple bond. My carbon count has stayed the same so far. After I add the alkyne, I want to deprotonate this using NaNH2. And once I had that deprotonated, there's a minus charge there, then I just want to add a CH3Br. So this will be my SN2 reaction. This will attack there. And then I now have my CH3 group added. To get to the E double bond, I need to use NaNH3, the liquid form. And that's how we would do that synthesis. In this one here, I'm going to make my observations first. I have a ketone. Here I started with 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I've added 2 carbons. So ways that I know how to get a ketone involve an alkyne. So maybe I had that. So I could have had this alkyne here. There's 4 carbons here. So this could also have from that alkyne. And to get the alkyne for either of these, we need to go through this or this. And then if I look at this one, it will be quicker to use this route over here because that is that one. So now if I go in my forward direction, I use Br2. BR, excess NaNH2. One, two, three, 4. And then I want to add my carbons. I already have 4 carbons, 1, 2, 3, 4. I'm adding 2 more onto here. And then at this point, you can add the 9-BBN, H2O2, OH minus. And you could add the 9-BBN or you could do the HgSO4, H2SO4. And that is because this is symmetric and it will go either way to get you this product. So I mentioned here you could have made the ketone or the aldehyde at this point, but then it would be very hard to make the carbon bonds. So anytime that you need to make carbon bonds, you want to do that before you change the functional group after. If I was to do the 9-BBN or the H2SO4 here, let's say I use the 9-BBN, I would have the aldehyde. And right now you have no ways of going from aldehyde to adding 2 carbons onto there. So you want to make sure that you add your carbons before you do the final functional group transformation. All right, for this reaction, we'll list our observations. I have 1, 2, 3. This is the same isopropyl group. And then from there, I have 1, 2, 3, 4. 1, 2, 3, 4. So I'm adding these 2 carbons. And then I have a halohydrin. And the alkyne is gone. So if I'm working backwards here, I can make a halohydrin from an alkene. I can make an alkene from an alkyne. And I can extend the carbons once I have the alkyne. So that goes back to this step. So if I start here, we start with NaNH2, and I'm adding 2 carbons. I can use ethyl iodide. So we want to add our carbons first before we do anything else. If I had reduced this to the double bond, I wouldn't be able to add the carbons. So make sure you add your carbons first. So once I have the double bond, and now I need a Z. That is Z, so I need to use H2 Lindlers. So I have the Z double bond, and then I can add Br2 H2O to get the halohydrin. Okay, in this reaction, That tert butyl group looks like this one. So there's these two carbons probably came from these two. So I've added carbons. And I have an alkyne. So if you like to move forward, we can do that, with the thought in the back of your mind that you have to get to an alkyne so that you can add this. So if I want to go to an alkyne, I need to add a halogen. Now we'll add 2 bars across the double bond. Excess NaNH2. We need water. So we get the alkyne. And now we can go right to here. This is the part of the molecule that is being added. So we're going to add NaNH2 to make it the alkylide. And then when you try to figure out what group is being added here, if it looks different than a CH3 or a CH2CH3, you can just draw what is there. This is the 4 carbons that I'm adding, and then add a leaving group to that. And that's how you could do that reaction. Observations. We have a syndiol. We have 2 extra carbons. And there's no alkyne anymore. So if I work forward with this one, usually where the functional groups is where your functional group handles are. Here is my functional group. These 2 carbons are going to be the same as these 2 carbons. So I need to add 2 carbons to that. And it'll be 1 on each side. So now I have this alkyne. I'm going to use NaNH3 liquid to get these E-alkene. Then I can use OSO4 and NMO. So that will give me my syndiol. So this would be one way to do that reaction. Another way to do it, we can use H2 Lindlar. Which would give us the cis double bond. And then I can do an anti-diol using RCO3H, H2O, and then when you rotate that bond, you'll get the same product here. So those are 2 different ways to do that. When we see these synthesis problems, there will be more than one correct answer. This is a similar problem, except now we have an anti-diol, and the triple bond is gone. Add 2 C's. The first steps will be the same. We're going to extend the chain first. So we add 1 carbon, and 2 carbons. And then if you use NaNH3, that will give us these E double bond. And then to do the anti here, we'd use the RCO3H, H2O. That would get you that. Or here you can use the H2 Lindlar. KMNO4, sodium hydroxide. that will give you this, and then when you rotate the bond to look like that, it will be the same product. So again, there's two different ways to do these reactions. When you're going through your synthesis problems, note the observations, what is different about the molecule, try to figure out where your functional group handles are, and work out from there.